Good afternoon. I'm going to do now one of these double award physics. So again, you should have a copy of this and you should have a copy of the mark scheme with you. And you work along with me and I'll show you the pitfalls and I'll show you what you have to do. So again, it's unit P1, it's the higher tier. It's June 27. You'll find this online. So let's have a look. So the first question is on kinetic energy. And the important thing about kinetic energy is that you know the formula. So the kinetic energy is half mv squared. Here you have it down here. Mv squared over 2 or a half mv squared. The important things is that you must have the mass in kilos. You must have the velocity in meters per second. There's the different ways of writing it. And the energy will be in joules. Now, if you can't rearrange formula, well, there will be questions, and you'll see them coming up, where they're going to ask you to find the velocity. So here are ways of rearranging the formula. You should learn this. So we'll do the first question. A footballer kicks a ball of 0.5 kilos. It's lovely, it's in kilos. The point of speed 8 meters per second. It's grand. So all you do is slot it in. You should try that in the calculator. See how you get on with that. So there's the first question. Straightforward recall. You need to know that formula. That's why I've put down learn here. So that's the first question done. Oh, part B of it. So it says on another occasion, a footballer gives the ball a total energy of 45 joules. Now, remember the total energy is both gravitational potential energy and kinetic energy. So you can see it here, I have it written down. Total energy is the kinetic energy and the potential energy. Sometimes that's called the mechanical energy, but years since I saw that question being asked. So we know that 45 joules is the total energy. Look, there's it there. And we know that 30 joules is kinetic energy. So therefore there must be 15 joules of potential energy. Now let's have a look at the potential energy formula. The potential energy formula is P equals mgh. So again, learn. You know it or you don't. If you don't know it, you can't do the question. So the mass is measured in kilos. G, we are on the planet Earth, is 10 meters per second squared, and the height will be in meters. So 15 is equal to 0.5 by 10 by h. 15 is equal to 5h. So some number I multiply it by 5, I get 15. The number is 3 meters, and the unit's there for us. So there's the first question. Again, how many marks was that for that first question? We're talking 3 and 4, 7. 10% of the paper on one question. So you should be looking at your energy. Next question up is it's a distance time graph. And I keep saying, when you look at these graphs, don't be confused with a distance time and a velocity time. They are totally different. So I know this is a distance time because it says it there. Distance versus time. Go to the bottom here. You should be writing this as your exam technique. There's only two things I can tell from a distance time graph. I can tell the distance at a certain time. Just cross that T. And the slope or the gradient is the speed. And again, gradient, a rise over a run. So that's all I can really ask. So during what intervals is the cyclist traveling faster? So that'll be the greatest gradient. Now, again, we're going for overkill. Which one's the greatest gradient? Well, there's it there. But to make sure that we get the time right, there's it there. It's 10 seconds. So it's 0 to 10 seconds. Right? You are advised to calculate his speed during the last 25. Look, there's 25 and there's 50. The last 25. He has went from 25 to 60. Sorry, 30. See, I even get it wrong. That's 30 to 60. So his distance is 30. His time is 25. So his speed is 1.2. So always take great time and care to read the units. So that was a handy look. 4 and 1's 5 marks for that. Again, another formula. If you went to your mind maps, you would find the formula to learn. Ask your granny Do you know them? So it says an object falls from rest during its fall. No air resistance acts on the object. So what's the speed of the object? 3 seconds. Well, the value of g is 10 meters per second squared. So that means in every second it goes 10 meters per second faster. So in 3 seconds, it will be doing 30 meters per second. At the end of the first second, it'll be doing 10 meters per second. At the end of the second, it'll be doing 20 meters per second. And at the end of the third second, it'll be doing 30 meters per second. Because every second it accelerates by 10 meters per second squared. So every time, every 1 second, it goes 10 meters per second faster. So after 3 seconds, it's doing 30 meters per second. Calculate the average speed. Average speed is initial velocity, started from rest, 0. Final velocity, 30. It's not the time taken, it's over 2 in that case, because you're finding the average of 2 values. So it's 0 plus 30 over 2 is 15. So average speed, there's another equation to look. Average speed is u, your initial velocity, plus v, your final velocity, and divide by 2, because that is the 2 values. You're finding the average of 2 things. So there's your answer. Again, 4 marks for that. Again, look at my working out. I'm not rushing the thinking. Again, question number 3. It's words, so has to have a capital letter, has to have a full stop. And so some poor being has to read this, and some poor being has to make sense of this. So if you're writing gobbledygook, you will get no marks because they can't read it. So I'm going to look at here's the table. You could learn this. Alpha, beta, gamma. There's the symbols. 42HE. Naught E minus 1 or naught beta minus 1. Gamma naught naught. Charge is plus 2. The charge is minus 1. No charge. What's it stopped by? Paper. Beta is by aluminium foil. Gamma by lead. PB. Plumbum. For the Latin students amongst you. This ionizes a lot, this ionizes a little, and this ionizes very little. So you can see, look, for each type of radiation, state its relative charge, if any. Right, so alpha plus 2 relative to what? The electron, relative to the proton. Beta particle minus 1, because remember the beta particle is a fast moving electron from the neutron, or from the nucleus. So you remember a neutron splits to give you a proton and an electron. And that electron is fired out. So that's how you get electron from the nucleus. So, state of danger of working with radioactive substances. Well, I'm going to look at the mark scheme and it says, state of danger of working with radioactive, it disrupts cells or causes cancer. People should stay far away from radioactive sources whilst using them. Give a practical way of doing this. Use tongs or robotic arm, and even if you're under 16, you shouldn't even be in the room. So you couldn't stay far enough away if you're not in the room. Now the next thing, on to question number 4. Explain the meaning of the terms half-life. Now I am going to go to the mark scheme, and this comes up time at a number. It's the time for the activity or count rate to halve. That's what you need. So you have to learn that. It says a radioactive substance has a half-life of 3 days. Initially, the substance has 14,000 undecayed nuclei. By first finding the number of undecayed nuclei after 9 days, calculate the number of nuclei that have decayed. Now be careful here. Here's the table. There's the number of nuclei. 14,000, 7,000, 3,500, 1,750. Let's look at the half-life. No half-life, 1, 2, 3. Look at the days. Now here comes the sneaky examiner thing. He wants to know how, or he or she wants to know how many have decayed. So there's how many is decayed. Sorry, there's the number that have not decayed. We started off with 14,000. That number hasn't decayed. I can't see that. Oh no. Hold on, I'm just going to adjust this slightly. Right, go back to this again. That's the number that's left. They have not decayed. That's the number that has decayed because it has to equal the total at the start. So that's the total. That's the number that has decayed. That's the ones that are left. So titanium TC is a radioactive element used in hospitals. It is made when molybdenum emits a negatively charged radioactive particle, an incomplete equation. So remember these incomplete equations. The numbers along the top have to add up. The numbers along the bottom have to add up. You need to know your alpha, beta, and gamma. They're there. You learn them. So 99 plus nothing gives you 99. 43 minus 1 gives you 42. There's the symbol for the beta particle, fast moving electron, or a beta particle. 5 marks for that. 1, 2, 3, 4, 5. 5 marks for that. That is one big hitting question. Learn them. Numbers along the top add up. Numbers along the bottom add up. We know the symbols. We have learned this table. Now, it talks about ionization here, so I've done this little diagram out. So there's a neutral atom. Now, the neutral atom has the same number of protons as electrons. That's why it's neutral. The electrons are -1, the protons are +1. So they cancel each other out if it's a neutral atom. Now, as you can see here, for some reason it loses an electron. You're not really interested why it loses it. So therefore, this becomes a positive ion because it has lost 1 electron. So it has more protons than electrons. Note, you can't get rid of protons. You can only gain or lose electrons. Now here's your negative ion. Neutral atom. Again, same number of protons in the nucleus as the electrons orbiting on the outer shells. For some reason, this gains an electron and it becomes a negative ion. Plays for Northern Ireland. More E's than P's. Remember, only E's can shift. So a neutral atom has lost or gained an electron is when something becomes ionized. It can become positively ionized or negatively ionized. Learn that. Next question. A student adds 5 newtons of water to an empty container of weight 3 newtons. Now, the total weight is 8 newtons. Always be careful when they're adding or subtracting weights or volumes. The pressure exerted on the bench is 160 pascals. Right, here's the formula. Pressure equals force over area. The pressure is measured in pascals. The force is measured in newtons. And area is measured in meters squared if it's pascals. Right? Again, I've done one of the simple how to rearrange a formula over here. You take your time in the exam. So pressure equals force over area. Don't forget the total weight was 8. So the area is equal to 8 over 160. Now please don't be stupid. Take the calculator out. There will be people in our midst that will do 160 divided by 8, but they will be wrong. So it's, talk to yourself, 8 divided by 160. 8 divided by 160. 0.05. See? 0.05. 5 marks for that. See the nasty trick? That's that one done. And again, look, there's no unit in this question. Meters squared. Yes? You see? Sometimes you should be checking each one to see do they need a unit. You should learn the units. Go on to the next one. What does a vector? So vectors, I've done a bit of a list here. Scalar, they have size only, distance, time, speed, energy. Most people get that wrong. Mass, vectors, force or weight, same thing. Acceleration, velocity, and displacement. Now there's some for you to learn. What does a vector quantity have a scalar quantity does not? Remember, a vector has magnitude and direction. Terrible fancy name just for size. So size and direction. So force, weight is a force, force is a weight, it's a vector. Area is a scalar. Scalars have magnitude only. Vectors, magnitude and direction. Learn that. On to question number 6. Now you have to be careful of these things. You see these distances. This is where the examiner's trying to cod you into getting it wrong. A workman uses a rope and pulley to raise a block of mass 30 kilos. Now remember, 30 kilos has a weight of 300 newtons from the ground. So what does he really lift that? 4 meters. Do you see this 1.5 meters? That's known as a red herring. It has nothing to do with the question. He only raised it 4 meters. Calculate the work done in raising the block to its new position. Work done equals force by distance. Another one for you to learn. If you don't know it, somebody else, they'll get your mark. Work done equals force by distance. Now there's the trick. Look, do you see? It's 30 kilos. But 30 kilos has a weight, a force of 300 newtons. W equals mg by 4, 1200 joules. They do give you the answer here, so it's grand. 1200 joules. Next question. Again, the examiner is not your friend. He or she is setting these pitfalls for you to fall into. So we're looking for power here. And power is equal to energy over time. Power has a unit of watts. Energy is the unit of joules. And the time is measured in seconds. Look what they've done. They have put 1 minute, 60 seconds. So power equals work done over time taken. Work done is the same as energy over time. Same equation. So it's 1200 over the time. 1200 over 60. 60 seconds. 20 watts. Look, watts. Lucky enough they have given this to you. In practice, the pulley exerts a force of friction. In lifting the block the same height, does the workman do more work, less work, or the same? Well, he's going to have to overcome the forces of friction, so he's going to have to do more work. If it was frictionless, he would just do that amount of work. Next question. Now it's a Hooke's law question. Again, there's the equation that you need to know for Hooke's law. The force that causes the extension is equal to a constant. Remember the graph. Force against extension. Directly proportional. Look at the way I'm labeling the graph. Because through the origin, it's directly proportional. Force is directly proportional to extension. Big extension, like over here, big force. Small extension, small force. Must get tablets for that. A load of 12 newtons is added to a spring but not released. Now I put a warning in here. It's extension. New length minus old length. The distance from the top of the spring, look, it was 30 centimeters long. It is now 38 millimeters long. It has extended 8 millimeters. What that 3 millimeters is for? No idea. Another red herring. You're to calculate the spring constant. Look, there's the spring constant, K. Remember, do a bit of mapping. F equals K times E. Straight line formula. Y equals mx plus c. There you have it. The gradient is the spring constant. The gradient is the spring constant. In this case, we're going to use 12 newtons, causes an 8 millimeter extension. What's the spring constant? 12 over 8. Now be careful. Look at the unit. Newtons. That's measured in newtons divided by millimeters. So it'll be newtons per millimeter, or newtons millimeters to minus 1. There was a mark for that. Keep watching. Every mark's a victim. Next one. Here's the graph. It's a force against extension graph. We're going to do the mapping. Do you remember we did the mapping on the other page? The force is on the y-axis. The extension is on the x-axis. The gradient is the gradient m. In your maths, you know that m is the gradient. That is the spring constant. Right? So, an engineer is given a data sheet with a force extension graph and 3. Unfortunately, the numbers were missing from the axis. So now it wasn't done right. The engineer needs the spring constant with the smallest spring constant. Smallest gradient. Which one is the smallest gradient? A. So there's that question. You look at the mark scheme. Let's have a look at the mark scheme. There's the mark scheme. Yes? Look at the marks. Are you working for every mark? On to the next question. It's a velocity time graph. How do I know it's a velocity time graph? It says so. It says so. Look at it. On a velocity time graph, you can only tell 3 things. Velocity at a certain time. Cross that T. The gradient is the acceleration. Cross that T. And the area enclosed is the displacement. So that's all they can ask from a velocity time graph. It's not a distance time graph. Not. It's a velocity time graph. Those are the 3 things. Just set this to the side. Coming near the end. Thank God for that. Choose the letters A, B, or C of the following. Which constant velocity? Which velocity does not change? B. This velocity changes with time. This velocity changes with time. B does not change. It stays the same. Which Newton's law would that one be? First law. Which of the graphs are the forces acting in the balance? Balanced. Remember Newton. First law. Second law. Balanced. Unbalanced. So, and then unbalanced. It can be stopped. Or constant speed. Right? So that's why it's B. Which graph shows constant acceleration? Look at here. The gradient is the acceleration. Is the gradient constant? Yes, the gradient is constant. Hasn't changed. So it's A and C. A and C. And the last question. The object in graph C, there's graph C, starts at 4, ends at 8, takes 5 seconds for it to do. The object in graph C is acted upon by a force of 12 newtons. Calculate the mass of the body. So the gradient is the acceleration. How do I know that? I have it written down. I'm going to find the acceleration. Look. A rise over run. So that's 4 over 5. 4 over 5. Do the calculator. 0.8 meters per second squared. That's the acceleration. Isaac Newton's second law. Here's it up here. Resultant force equals mass by acceleration. Tells me the resultant force is 12. Mass. Again, look. If you can't rearrange formula, keep it simple, stupid. 12 is equal to mass by 0.8. Now don't fall for this. Get the calculator out and do the sum. 12 divided by 0.8. 15. So the mass is 15. There's no mark for the unit. It's already there. And that's the end of that paper. See you shortly.